Hello there. First of all, thank you for having me. It's a really great honor to be here and talk about myself and some of the catches that I see in my experience, and to give away some little bit of expertise that I have that I found on some of the complex field. And what good of opportunity can it be? It's already like Talker's birthday. It's really special events. So exciting. So yeah, let's talk about myself. My name is Talha. People call me Talha in my native language, but some call me Tal for sure. Doesn't matter. It's good anyway. So yeah, I've been programmer almost all my life, and I knew that I wanted to do this. A fun story actually. So basically, um, I'm a born engineer. When I say born, I mean I knew I wanted to do this, and I knew I had a thing for this when I wasn't even in high school. I wasn't even done with my school, and I was thinking about problems like, hey, how do people do this echo in their sound, in their voice? How do these mics work? So in my mind, I was just thinking, oh, how about we raise a bar, we raise a thread, and then maybe the other thread goes after 2, 3 seconds, and maybe the volume is tiny bit lower, and so on. Maybe we raise the third bar and make volume even lower and put a little bit more delay. So to my surprise, I was really shocked to see as a kid that this actually happened. I think it's not a good idea to speak about the name of a software that I use for copyright reason, but I use some softwares that had the same kind of experience, the same kind of logic that I was thinking as a kid. So I knew right away, this is my thing. This is something I'm good at. The abstract, the problem solving is what I do. So here we go. I started my career even before I graduated in my high school days. So this is how you may wonder how come I can have such an experience in the age of 24, 25. So yeah, I've been around playing with full stack JavaScript with more than 8 plus years, touching almost every fields on web, mobile, hardware interfacing. Some of the cool things uh, that I did was hardware interfacing, but yeah, that is almost like enough about myself. Let's see where I'm at. So yeah, I'm from Pakistan, from a city called Faisalabad. It's called Faisalabad in my native, but you can call it Faisalabad. Yep. So yeah, so it's the third largest city. It's amazing actually. It's a developing city with many of the perks, and yeah, the surprises are listed. It's the eighth biggest textile exported in the Asia, in whole Asia actually. And yeah, the textile, the cotton, fabric, clothes, this is the main industry that Pakistan exports, and like 48% of the world is manufactured in here, or comes and goes out from here. So yeah, it's definitely not a desert like the movies shows you. So it's really fun. Here's a picture of the main landmark, the watchtower of Faisalabad. It's really active streets. Each street have their own market. Each market is dedicated around some good, and as long as you walk, like this is the snapshot from a drone. As long as you walk even till the end of the streets, you will find the same old product throughout the street, unless you change it. So yeah, there are way too many fun things around here. The phone lands, you can book a private jet, you can do paintball ball fights, you can do more like ghost towns. Yeah, the artificial ones. So we have a lot of fun there. We have a lot of industrial and even growing, and yep, the fabric in the last. So let's talk about the main purpose. The main thing I wanted to talk about is Elasticsearch. What is Elasticsearch? Why come people use it or may not want to use it? And how come Docker can solve some of the problems in here? What actually is the features that Elasticsearch can give us uh, compared to other DBs. So Elasticsearch is kind of like a hybrid. It's a search engine. It can be used as a DB. It can be used as a full stack, but it's not really uh, strictly NoSQL. It's not really strictly a relational. It's a mixture. So it depends on you how you want it to use it, and this is how the complexity arises, because the more freedom you have, the more confusing it get, and you just don't know where to look for what exactly is uh what exactly are the catches. So all of these things you know by expertise, you know by trial and errors. Honestly, like it's just development tools or official clients, it's like non-existent. So this is how it's really important for me right now to speak on it, and this is why I wanted to choose this. Let's go a little bit formal about what Elasticsearch can do and what is a real world example. So Elasticsearch, you might have seen Algolia, like you might have seen it on CDN somewhere. So it's really fast, it's really good that you want to do some kind of aggregated text search, then Elasticsearch is your main DB to choose. Or maybe you want to have some schema that you want to compress. Maybe you have a very nested schema you want to compress into very tiny valuable information. Then Elasticsearch is also your tool. And honestly, it's just like a thing behind the scene that nobody knows about, that is powering a lot of things like Kibana, for example. A lot of the cloud searches like AWS or GWS are using it behind the scenes for their loggings, and a lot of other third-party tools are also using it for the logging. So yeah, uh, we'll talk about a little bit about some of the catches. Obviously I cannot talk like the whole best practices or the catches, but I will talk about just a little bit, just enough to get started and do a little bit of demonstration, and then we'll talk about how Docker can simplify things and what are exactly things that Docker can simplify. Let's go. So first thing, the very common problem that I face, that I see people do it, is the Leucine problem. It's uh behind the scene, it's I mean, when you talk about Leucine problem, people think about, hey, is it the third part, is it the open source software that Elasticsearch use, is that the problem? No, actually not. It's basically the docs we are talking about. So when you add something in the Elasticsearch, in other databases it's called a row, it's called a column, but here it's called a doc. Just like how you would do in the MongoDB or any other NoSQL, it's called a doc. So here we call it a doc. You have some and the main problem arises when you insert something that is nested, and this is where you want to think ahead. This is where you want to be really strategic about your database designs, because this problem doesn't look like a problem until your data gets bigger and bigger, and then you get it harder to do very simple operations like just accounting. For example, you have this very simple JSON, you have this very simple doc, and you want to get a count. Technically, it's just a one count because we see that there is only one index or one row, whichever you may want to call it. But when you do a count query on it, you will actually get a 8 because it's gonna count all the indexes. And this is where the problem comes out, because Elasticsearch behind the scene would slice off your doc and go deep down the nest level. This is where you also limit or define in the configuration, but it's a whole new different topic. So here Docker will Elasticsearch will go down some levels and try to count them and try to index them. It's a good thing and a bad thing. The good thing is maybe this is what you want, and you don't have to do any configuration. It's coming out to you out of the box. but the bad thing, maybe it's not something you want, and to solve this is really hard a problem. So how do we solve this is by using best practice. Obviously, there are some scripts or some workaround that you can do, but I believe the best practice, the infrastructure is the go-to, is a main thing that solves a lot of problem even before they arises. So let's see our problem in a little bit more zoom condition. So here I have like two indexes. So in Elasticsearch, you call indice. Oh, the table is called indice. So we have two indices, or maybe you can call it database. So we have these two indices. They are same in size, but you will see there the Leucine docs. One is about 28,000 and other is about 6,000. But in reality, both of them have the same amount of indexes. The only difference is that in one index, in properties dash flat, what I did is instead of putting the next nested index, I just compress it and I put it there. So this is one big best practices, or you can say must practices to do that. If you want to use your Elasticsearch, you just need to be aware that your data model should be compressed. Maybe you have very nested level. Maybe you have historical data. You have something called daily snapshot. Maybe you are doing a visitor log, or some price log. Maybe you want a forex or something. So whatever you do, you just want to keep your Elasticsearch indexes as flat as possible to avoid these nesting. And the more lesser nesting you have, the more better it will get, because it will not index the useless items, and it will give you the speed on your hot indexes. This is a term called hot indexes. It's a whole different topic. In Elasticsearch, a thing that get accessed more and more, it becomes hot. It becomes like cached, or just in the memory. So it's a lot more easier to access, a lot more faster to access if someone is to query that. Moving on, migration problem. So yeah, migration problem comes in all the other databases, like maybe relational or even NoSQL like Mongo. You have some tool to migrate. Maybe you want to rename a column. Maybe you want to uh, change the data type. So in other places, you have tools, you have ways to do that, but in Elasticsearch, it's really, if not impossible, but really hard to do that, because let's say you have something called you added some uh, columns, you added some indexes that is like this address, and then you did some nesting something, and in there you put some category and name. Maybe you want another nest detail for the name or for the something, and then you want few more indexes inside of it. Maybe you want to keep on going. So when doing Elasticsearch, there are two kind of migrations, or mapping, if we say. So one mapping is dynamic mapping. You just put a thing like, for example, address was not there for like you already had 10,000, 20,000 rows. You already have these many records, but the address was not there. For 20,001 index, you decided to put an address there. It's totally fine. What Elasticsearch will do is it will do a dynamic mapping. It will see what kind of data it is coming. So if it's a text, it's going to mark the address as text forever. So it's really hard to change that back, because it will get synced to all other rows that you have, and it will become really hard. This is what people normally do, that they want to avail some scenarios, they want to avail this NoSQL freedom, they want to just keep on pushing the indexes. But in your NoSQL like Mongo, you have more flexibility. You can just change some string to integer or some integer to string back. It's no big problem. But in Elasticsearch, if you want to do that, it's almost nearly impossible. You will have to like download your whole indice, do some kind of mapping or transformation, then upload to a new indice, and kind of delete your old one. Or there are some workarounds which should take you almost the same time it would take to do this manual downloading and uploading. So what you should do instead is just try to minimize and think ahead. What are the possible indexes that you can have? What are the possible data types that you can have? And try as much as possible to not change the existing data type. This is something you really need to do. And how do you do that is by doing something like a put request, the rest full API, whatever your index name is, or we can call it indice. So my indice can be ABC. I will do like underscore mapping, and inside the properties, I will put something like ID, address, category, whatever, and then I will define it, what kind of type it is. This way you will have a boilerplate, you will have a strong base, a foundation that you can use to grow your data without running into complications like some oopsies, that you want to change some index name to index ABC or address XYZ. This is where the problem really comes in. Now, to talk about our special guest is, or special feature is GeoSpatial. It's a really, really advanced field. It's a really exciting field, and something that Elasticsearch apparently supports, and how a lot of the apps like Lyft, Uber are using on their Google maps to show some kind of different drivings or different features. So behind the scene, Elasticsearch is really handling it really well. So let's talk about what geospatial is. Some people call it geosphere, some call it GeoGIS, or whatever you may call it. We can call it map for simple. What map is, it says the street data, what street, what road, and where are what kind of building, and what are the lands, right? What are the mountains? And then just attaching some numeric coordinates to it, how our globe works. And there you have it. You have your map, you have your geospatial. So in our talk, we'll talk about how to set up a really blank map, and how to perform a really uh, simple query about the map boundary. The map boundary is your visible map. You have an app open, you swipe to left, you swipe to right. When you stop swiping, when you leave your hand, and in the viewport, the screen, the map on your screen is, maybe let's say you were in Dallas and now you're in San Francisco. So you had something on Dallas, or sorry, something on San Francisco. System will not load it. Your map will capture that boundary, and it will send to Elasticsearch, and Elasticsearch will fantastically read it, and read all the markers, or read all the data that it have, and return it. So this is a really awesome feature that Elasticsearch is providing, and really complex one too, because Elasticsearch by default mostly demonstrate or shows how you could do the same thing in REST APIs, but doesn't really go in detail about the libraries or the languages. Maybe you want something in Angular on React. Maybe you want something in Node or Java's, but you don't really get to have all of these language specific design docs, or docs. You just have some very generic information on the doc. This is how it's really hard to get started with Elasticsearch. But yeah, it's a worth doing it. It's a worth doing trial and error, and just finding your own way to understand and get familiar. Now let's deep dive into Docker magic and see where Docker can help and what Docker really does before we go into the demonstration. So Docker, for those of you who know it, I call Docker a magic because before, in old days, we had to do some VM machines. We had to, if we want to run an exe, if we want to run an dep, some DMG, whatever OS specific file you may have, you want to run it, and you don't have any other computer than your a single computer, a single OS. And it's really hard. You have to do a lot of, let's say, WineHQ, or you have to do VM machine, and sometimes it's really resource exhausting experience. How Docker does it, Docker does not download the whole thing. It just download the dependencies, the kernels or whatnot, the drivers, and run your application without compromising your space, without compromising your resources. And this is the main Docker magic. Docker has grown so much. It's now picked with by industries to do a lot of things like microservices, the standalone portable tiny pieces of one infrastructure instead of the monolithic one. And this is how the whole AWS, the whole GWS, or all these cloud storage came to be. They became scalable, and all of these magic was behind the scene, this ideology of making your features as portable as possible, and putting them in containers, and doing all of these serverless functions. And all of this is possible by this one initiative. So let's see how Docker does it. We first thing we Docker can does is the dependency, obviously, maybe the OS dependency, maybe the library dependency. It's where Docker can automate it for you, install it for you, and you don't have to install anywhere else. You just have this one information, the one configuration you put on somebody's computer or some server, and Docker will just do it in one command. Other thing we can do, that Docker can do, is run your scripts. So your initializing script. So in here I have it as ES mapping because it's something that I feel I need to do before I run my build. It's where Docker can do it. But you may have a different scenario. Maybe you don't want to do an ES mapping. Maybe you want to do some DB maybe some DB mapping, or maybe you just want to ping a server to say, hey, I installed this thing on this computer. So yeah, that is something you can do with Docker. Last thing is deploying. It's a really huge topic and something that needs way too much time. So what deployment, how Docker help us in deployment is by creating a container, creating a package that we can take anywhere, and we don't need to do like a different kind of environments. We don't have to uh, spawn a different kind of servers. We just need to change the environment. You would just need to change something like the keys. So maybe in your production you have let's say Google Map version 1 to 3, maybe it's a red version something, or in staging it's a blue. So this is just an example that once the packaging is done, once the container is done, you can very well define the env inside of it, and your whole app, without changing or modifying to the very core, you can just deploy it and get the most out of it. Now we will go to the implementation and just see a little bit of demonstration how you can do it. So here I have a Docker compose file. This is your go-to file, your getting started file that you need to do. Then you have a Docker file that I have right here. So you can install something like a program, you can install something like a service or an image, we call it. So here I need Elasticsearch image, right? So what I can do is simply type in service and type in whatever the name I want it to give. It's not strictly Elasticsearch, it can be anything. The main thing depends on what your image you're using. So I'm using this 710 image from Docker, and I can do some environment, and these environment also include environment that the program itself supports, like a flag tag. So you can say, hey, I want 1 gigs of RAM to this thing. So this is where your environment will work if your image supports it, right? Something like a Puppeteer. So Puppeteer gives you a lot of environments to set, and this is how you can just take advantage. Then we have something like UL image is just another topic where you freeze the memory or space in your memory so the pager doesn't give out. Next thing, the important thing is just the volumes where it's installed and how you want to read it. So I just mounted this in the ES and I have this volume information here where exactly I want it to do, what kind of driver I want. And lastly, the very important part is the ports. Like, because when your service is running, the service may be returning you some kind of a port, and you may want to project that port out of your Docker. So this is your in and out, and you just map it. For example, the in can be 9200, but out can be 888. It's really depends on you how you want it to it. Next thing, let's go to Elasticsearch. What I have in here, I have something tiny like a mapping. So in this mapping, I simply have one field. It's just called coordinates. So I made a field. Coordinates is something that you will know more about in the Elasticsearch docs, how you can set it. So I have this coordinate, then I have a simple seed, which I will seed it by using my query, my script that I wrote. I'm just deleting and reinserting something. So all of these things are the dependency is something that one person needs to do manually, and it's really, really hard to do manually if you have no access to the root server, for example. Maybe you are putting in Elasticsearch in your EC2 and you don't really have access to SSH. So how do you do it? You just put it in the Docker and you say, hey, I want this thing, and Docker will run that for you. So you can do it something like this, or you can do something like that. The run npm run setup, in my run setup, I'm just running this Elasticsearch setup file, or in your start, you can also do some pre-start, and it will run the setup. The Docker file will simply copy your files and create a package. So that's the simple thing about Docker file. All right, let's see what I did in the controller or just in my route. So I simply have one Express server somewhere in the hidden files, and in here I'm sending the request and resource from Express, and where I'm getting this southwest and northeast coordinates, and then I'm just searching these coordinates inside my function. So yeah, in here, this is the geobounding box. This is a reserved feature. This is a reserved keyword that you can use to indicate that what kind of operation you want in MongoDB. And somewhere else, you had something like OP EQ or equal or greater than and equal. So it's just an equivalent to that. So we do that and we provide the top right and bottom left coordinates to it. So it may come at string or something. I'm just mapping it as a number. Lastly, you just want to search by using a node library and by providing your index name as an index and just returning by doing a map. So that's really straightforward. That's really tiny how you can do a very tiny Elasticsearch geospatial feature. Let's see in action how does it look like. So it will look something like this, where you have some different markers and you can scroll in, scroll out, drag in, drag out, and it will then render all of those markers for you. So notice that I don't really have any marker on this side of map because I'm not really leaving it yet, but once I leave and once the query runs, it will try to fetch and put one more marker here because it's there. So this is just an example and how you too can implement, and how the Docker can help simplify this whole experience. That is it. And yeah, this has been a very great experience. It's been a very great opportunity. I'm really, really humbled and grateful to be able to speak in front of all the community on a very special occasion on Talker's birthday. And yeah, that's really exciting. That's really, really rewarding in itself. That's all. Thank you so much. And yeah, hey, Docker, happy birthday. Yeah.